In this video, we're going to begin rewriting literal expressions by reducing common factors after rewriting fractions. Here's an example. Say that you have a solution that looks like this, and you'd prefer to write it in a different form so that it looks like this. One technique would be to start with your original fraction and write it as two fractions, both which have the common denominator. Next, you'll notice that the 2's can now reduce because they're factors of products. We couldn't reduce the 2's here because this term is part of a difference. Once we rewrite it though, this is now a product and the 2's can be reduced. The last technique we need to get comfortable with to rewrite it into this form is the idea that dividing by 2 and multiplying by 1/2 are equivalent. You can think of p divided by 2 as p over 1 times 1/2. And there's no real need for the parentheses, we can just remove them. Now, this idea of rewriting from fractions to products is very, very common in algebra. So it's a really nice technique to get good at. Here's one for you to try. Can you rewrite this quotient as this difference? First, we're going to write two fractions, each of which has the common denominator. Now you'll notice the factors of x2 can reduce, leaving x1. The factors of x2 can reduce, simply leaving a 1. Here's another one to try. After rewriting as fractions, I notice the 8's can reduce to a factor of 1. The 16 over 8 can reduce to a factor of 2. The common factors can reduce to a 1. And I get to here. And see if you can do this one. After rewriting, 32 and 64 will reduce to a denominator of 2. And 64 over 64 will reduce to a factor of 1. Then I have to think of dividing by 2 as multiplying by 1/2 and bring this factor of -1 out front. It's very common for the factor of -1 to be in front of the 1/2, for instance. Try this one. After rewriting, I notice the 6 and 3 reduced to 2, and the 3 and the 3 reduced to a factor of 1. Now notice we're still not to the form we're after, but that's because sums are commutative, and so we could write this as square root of c plus -2. And we often write adding a negative as subtraction. So that's one way of rewriting literal expressions. And here's another, working with factors of -1. It's common when you have a lot of negatives and subtractions to multiply both the numerator and the denominator by -1. That means you're simply multiplying by 1, so you won't change the value. When you multiply here in the numerator, for instance, we'll get a positive 1. And when we distribute, we'll get -1 plus x. Of course, we usually rewrite this into standard form, writing it as x plus -1, or just x minus 1. Here's one for you to try. Noticing that I need to work with the radicand, I'm going to multiply the numerator and the denominator by -1. I'll distribute and get negative h plus 50 and a positive 16. Again, we usually rewrite a sum like this as 50 plus negative h, and that's often written as just 50 minus h. Here's another. After multiplying both the numerator and denominator by negative 1, and then distributing, I'll get positive a1 plus positive a naught, and in the denominator I'll just get positive a. Here's another. After multiplying both by negative 1, I see that I get negative root 2 plus root x, and positive 1 plus 2 roots of x. In the numerator, I'm going to rewrite this as root x plus negative root 2, and that again is just usually written as root x minus root 2. Notice I also rewrote the denominator to match the form I was after. Well, that concludes this video where we learned two techniques for rewriting literal expressions.